Students, this is the homework help page for lesson 6.4. Remember, you should only be taking a look at this after 20 minutes of solid individual effort and perseverance on your part. Do not immediately default to this page. Work yourself through these 14 steps on your own, which is what you can do when you don't know what to do. If you have exhausted those steps, let's take a look at problem number 6. Finger track and underline with me. It says if the sum of the interior angles of a regular polygon equals 270, what does a single exterior angle measure? So we have several equations here. First, we have the equation, the sum of the interior angles of a regular polygon. So I'm going to write that equation out. Sum of interior angles of a polygon equals, and that's n minus 2 times 180. And then we have an equation. We have a single exterior angle, and we know it's regular. So we write 1 exterior angle, regular, and the equation for that is sum over sides, which is 360 over n. Problem is we don't know n here. So let's take a look at what we do know. We know something equals 2,700. And what equals that is the sum of the interior angles. So we know the sum of the interior angles equals 2,700. Notice that's being repeated. So we can substitute here sum of interior angles with 2,700 equals this right here, which is n minus 2 times 180. You're going to solve for n. And once you solve for n, it's the same n that's here, and then you could figure out what a single exterior angle would be in this case. Taking a look at number 7, it says, if the measures of 4 interior angles of a pentagon are, and you're given 4 of them, what is the measure of the 5th interior angle? Let's draw a picture of this. A pentagon is a 5-sided shape. So we don't know what this shape looks like, but we know it has 5 sides. We're giving 4, and they're interior, so they're inside. So we have 121, and we have 114, and we have 69, and then we have 92. We're being asked for the 5th interior angle, which is x degrees. So once again, if this is a triangle, you know that you simply add up the angles and take away from it 180, and we use 180 because for a triangle, the sum of the interior angles of a triangle equals 180. So the question is, what would be the sum of the interior angles of a pentagon? That's the question. So we write sum interior angle equals, it reads like this, the sum of interior angles, sides minus 2 times 180. Use that to find your sum. Once you have the sum, then you can easily solve for that 5th angle. Taking a look at number 8, it says in the diagram below, this is going to be a full side here, the diagram below, trace line M and N. So we're going to start by tracing lines M and N. We're going to do that in blue. And we're going to note that they are parallel. That's important. That's going to come into play. Put the little arrow feathers on there. We're going to use different colors to shade a single. So we're going to use colors here. We have a regular pentagon. It's a regular pentagon. That's right here. A regular pentagon. 1, 2, 3, 4, 5. We have a regular pentagon. And we have a regular hexagon. 1, 2, 3, 4, 5, 6. And we have an isosceles triangle right here. Using this information, we want to find all possible angles. Now don't freak out because your first thought is there's nothing given. Well, keep in mind I just told you that both this shape and this shape are regular shapes, which means we can use the one angle equation, which is one angle, a single angle of an interior shape equals sum over sides, n minus 2 times 180 over n. That's going to get you a single interior angle. That equation is going to work both for finding the measure of one angle in this pentagon, as well as finding one angle in this hexagon. Once you have both of those, you're able to find all the other shapes. Taking a look here, it says a trapezoid, number 9. A trapezoid has a median length of 52 inches. The longer base is 70 inches. Find the measure of the shorter base. Let's draw this before you freak out here. It's a trapezoid. And we have our median here, which connects midpoints. And that is 52 inches. And our longer base is 70. And we want to find this shorter base, which we don't know. So this is 70 inches, and this is our x inches. Always write down, if you don't know how to do this, at least write your related equations. I just told you it's a trapezoid, and we have a median. So let's at least write our equation out, in which we have the median equals base plus base over 2. Use that equation to solve for x. Number 10. In polygon A, B, C, D, E, F, it is a regular hexagon, and the length of ON is 12 inches. And that's O to N, so from O to N, that is 12 inches. Find the perimeter of the hexagon. Keep in mind that is going to create a right angle here. We want to find the perimeter. So perimeter goes all the way around. 1, 2, 3, 4, 5, 6. So obviously we need to find this one side and simply times by 6. We'll call this x. Problem is you're given no information except this 12 down here, but we do notice that we have equilateral triangles here. So if that's 60, we have a vertical angle right here. Watch out for that vertical angle. That right there, if that's 60, that's 60, which forces this to be 30 and 30. Behold, we have a 30, 60, 90 triangle here. We're going to pull it out. And this length right here is 12. This is 30. This is 60. And we want to find the length of this side right here, because then we double it and we find the whole side. So using the 30, 60, 90 table, short leg, long leg, hypo, short leg, this is 2 times the short leg, and the short leg times root 3. Use this table to find your missing sides.